Okay. So here we have discussed the difference between elements, what are elements, what are atoms, and we have discussed that what are atoms, what are. We today we shall be going to discuss the types of mixture, homogeneous mixtures and these heterogeneous mixtures. Yes, we shall be going to discuss. Have you noted this the difference between the compound and mixtures? Everyone. Okay.
Yes, sir.
Yes, Saad and Sara and Hanan. Please turn on the camera. Okay. So we're just going to discuss the homogeneous and heterogeneous mixtures. So what are homogeneous mixtures? Let me explain what are homogeneous mixtures. Do we have discussed this one or not? I think one or two students were there. Discuss this one. So let's start studying this one again. Okay. So if I'm talking about the homogeneous mixture, what are homogeneous mixtures? Okay. So in the homogeneous mixtures are those mixtures that if I'm talking, okay, that has uniform composition. From the solution, they are going to have uniform composition. Okay, and if I'm talking uniform composition, uniform composition. What do you mean by the word uniform composition? Anybody in the class can tell me what do you mean by the word uniform? Uniform means similar, similar from all extent. Okay, like for example, you make a glass of water. Okay, and you take a sip of you make a solution like you make a glass of water, you add some sugar to it. Okay, and then you take the you dissolve the sugar properly. So if you dissolve the sugar completely, then if you take the sip of the water from the top or at the from the bottom, the sip will be same, means the taste will be same from all sides. It does not mean that it is going to have different compositions. Like in the previous class I have given you the examples of key. Okay, if you are taking key. Okay. So if I'm talking about the homogeneous and heterogeneous mixtures, okay, the homogeneous mixtures are those mixtures that has uniform composition throughout the solutions. Okay, that have uniform composition throughout the solutions. And means uniform composition means if you take it the sample from anywhere and multiple times, then it is going to give you the same composition. Moreover, if you take an example of like your mother make some halwa, and she added kaju, badam, pista, and that. So sometimes you might have kaju in there, you might have the kishmish for the next time. You can have the badam for the next time, or you can have the badam and kishmish for that. So this is not considered to be as uniform. Uniform composition means same at all time. Okay. So if you take a sip, if it is this kaju there, for the next time it will be kaju. So it means uniform composition. Okay? So uniform compositions, homogeneous mixtures have uniform composition throughout the solution. They are considered to be as true solution and they have uniform compositions. So next type of mixtures, if I'm talking here, is that is the heterogeneous mixtures. If I'm talking heterogeneous means that we have uniform composition. So don't turn off your camera. So I'm monitoring you. So if I'm talking that heterogeneous mixtures, so heterogeneous mixtures means those mixtures that don't have uniform compositions. Either they look like for example, the heterogeneous mixtures we have divided into two parts, the suspension and the colloids. Suspensions, if I'm talking about the suspensions, suspended, the word suspension come from the word suspended, and colloids come from the word colloidal solutions again. So if I'm talking about the suspend that do not remain in the solution, that something like for example, you have sand and water. So when you are having sand and water, so what you did, you dissolve sand in the water. Sometimes you keep the glass, you will find that all the particles of sand will get settled down. We call them suspension. What we call them? Suspension. And colloids, colloids are those samples. We'll consider that colloids mean these seems to be uniform, but they don't have uniform composition. Like for example, blood. Where do you see that blood is same, have uniform composition, but it doesn't have uniform composition. Like for example, milk. If you start drinking the milk, you will find that it will, but uh, there is something that colloids do not have, which the true solutions have. And we're going to discuss this one. Okay. Got it? What is that one? Let me explain you. Let me explain you that what is that one. So if I'm moving to the next part here, like what is the main difference between the colloidal and the suspension? Colloidal and suspensions. Okay. So let me explain you this one. So for examples, if you have like for example, light when if anything is visible to you, like you see table around you, okay, why the table is invisible when the light is turned on? Like because table have its own light. When the bulb light or the tube light is coming, then it gets scattered. Okay, it gets scattered from there and then reaches into your eyes. Okay, it gets scattered from there and then reaches into your eyes. So what actually anything make us visible, and how what is that thing that makes it is a reflected light from that position. It is we call it reflected light. Okay. So what is reflected light? What is reflected light? For example, if the light falls on the bed or on the table, then should it should reflect and should enter our eyes. If that is if reflection is being done, then it means that thing is visible to you. Otherwise, it is. So what is that a small thing that can be reflected? So that we can see that if you turn on the torch beam, you will find that a beam in the beam of torch you find that scattered particles, light particles are there. Sorry, dust particles are there. And why these dust particles are visible? Because the light is traveling, and in that part, the dust particle is becoming like an obstacle. Okay, like an obstacle. So this is the dust particle from the light is moving in the form of wave, and then it is scattered. This is scattered. Okay, it is scattered from everywhere. So if your eyes is here, this particle will be visible. If your eyes is here, the particle is visible. It will be scattered everywhere. So wherever your eyes is, if one of the ray will reaches to your eye, then this particle will be visible to you. So visibility of a particle is just when the light falls on that particle and it gets scattered. Okay. How if the particle size is so small, so small, so small that even though it cannot scatter the beam of light, means light, like for example, I'm saying that here in this box there is a particle, just here is a particle, but it is not visible. So the particle is so small that even though the light is not being scattered over here, if the light is not being scattered, so there will be no reflected light. And if there is no reflected light, the particle will not be visible to you. Particle will not be visible to you. If anyone of you, like for example, you went to the theater and you find that the projector beam is coming. So because in the theater there is a dust, okay, and thus because of that the beams are visible to you. Okay, if there is no dust, like for example, we use uh, air cleaner or what we call them is air filter. So if we use that air filter, all the dust will be consumed by that air air purifier, and there will be no path of light will be visible to you. Why? Because the dust particle is big enough that it can scatter the beam of light. That's why the path of light is visible. But how if all the dust, if, for example, if you have a chamber which is having vacuum, and if you are passing the light through it, the path of light will not be visible to you because there is no dust. Only what you see in the path of light. You will notice that these are the dust particles that are making the path of light visible. Dust particles are making the path of light visible. If there is no dust particle, no path of light will be visible to you. No path of light will be visible to you. Got it? So we'll simply say here that it is the only and only if I'm saying that okay, if I'm saying here that if the dust particle is so enough that the path of the light will be visible here, then if I'm saying that the particle is so small in size, that the particle is so small in size that it is not scattering the beam of light. So the path of light in the solution will not be visible. Will not be visible because the particle size is very, very small in size. And the path of the light will not be visible. Got it? Got it? You understood? So here
Yes.
we'll simply say that the path of the light is not visible. Why it is not visible? Just because it is not scattering the beam of light. Why it is visible here? Because it is the outside area and it is in here, they are the dust particles. So the dust particle will make the path visible and the path of light will be visible outside. So if you have a glass, RO water or slurry water. Okay, and you add a tablespoon fresh sugar or salt solution. So because the salt solution is because if it is pure, it is not having any impurities. Because okay, because there can be dust in the salt. Okay, if there is no dust in the salt, it is pure NaCl. When you dissolve it, then you scatter the beam of light through it. The path of light will not be visible in that. There will be no path of light will be visible. So that because the particle size is very small, that it cannot scatter the beam. Understood?
Yes, sir.
Yes or no? Understood. Okay. So here,
Yes.
if I'm saying that path of light is not visible here, and in case of colloidal solution, if I'm talking about the colloidal solution, so what happens in the colloidal solution? In the colloidal solution, uh, what happens actually? The particle is big enough that it will scatter the beam, and the path of light is visible. Like you take the blood and you pass the light through it, the path of light will be visible to it. The path of the light will be visible. Okay. So passing the light through blood, through milk, path of light will be visible. So it means the particle size is enough. Otherwise, true solution and colloids have almost same characteristics. They do not settle down when you keep it for long. The particle do not settle down. They have uniform composition. Okay, but the main difference between the colloidal solution and the true solution is that true solution do not scatter the beam of light. Do not scatter the beam of light. Okay? True solution do not scatter the beam of light. Okay, and when there is no scattering of beam will be there, then the path will not be there. Okay, got it? Got it? You understood?
Yes, sir.
And here also, in the milk, the path is visible. And this effect is called Tyndall effect. What we called it? This path, like you have seen in the region of forest. Okay, if the sunbeams are coming, you see there because they are in the when there are trees, forest. Okay, the sunbeam is coming, then you see that the sunlight is coming. The path of the light is visible because in that region the humidity is very high and the foggy structure is being formed. Okay, because of that the path of light is visible, and you have seen the sunlight coming during the daytime from a window. So the path in the day is just then particles of path of light is visible. Okay, so the path of light is visible only when if the particle size is big enough, right, that when the light is moving, it gets scattered with that particles. Okay, then the particles is visible, then path of light will be visible. Okay, understood? Like for example, if I'm saying that uh, if the light is traveling this way, okay, and here if I want to see the path of light, so I must shape this region like this. For this region, there must be the dust particles or the particle is size should be big enough that it can really scatter the beam of light. If there is no particle, the particle size is very, very small that it cannot scatter. So you will not be visible. The path of the light will not be visible. Got it? Yes or no?
Yes,
Okay.
yes. Yes, sir.
So we will say that shows true solution do not scatter the beam of light, means they don't show Tyndall effect, while the colloids and the suspension show Tyndall effect. Okay, Tyndall effect. Got it? So please note it down. This one first. Make this one just a minute. Make suspension because colloids are very close to suspension. So make this one like this. Make colloids here. And suspension there. Colloids and suspension. Make this one. Please. Do this one fast. Done, noted everyone?
Yes, sir.
Okay, do the next project here. Okay, make this one please. This is heterogeneous mixtures. It may be colloids or suspension, and this one is no path, no visible path of light. When you done, please write. Yes, Anam, how are you? Why your camera is turned off? Mohammed Rafe, please turn on the camera. Done?
Yes, sir. Yes, sir.
Next, please note down the difference between the two solutions, suspension and colloids. Anam, you there in the class? Anam, you're not responding, Anam. Okay, so what do you mean by the true solution? The true solution particle do not settle down. The same colloid solution also do not. Just stop writing, please. Concentrate here. True solution, same characteristics. You can check it. This is same and colloid is also same. Can't be separated by filtration. Can't be separated by filtration. The both can't be separated by filtration. Have uniform composition. Have uniform composition. It do not scatter the beam of light. It scatter the beam of light. Almost 1, 2, and 3 points are same. Okay, and we'll simply say, okay, got it.
Yes, sir.
And if I'm talking about the suspension, particles settle down, can be separated by filtration, do not have uniform composition, scatter the beam of light. All these are the points. Okay. Noted this one.
Yes, sir.
So are you noted?
No, sir.
Noted this.
Yes, sir.
So let's move further. And sometimes, is there anyone still writing? Okay, Bharti, you done? Samya, Sarah, and you?
Yes, sir.
Still doing.
Today, still doing. Do it fast. Done? Noted? Okay. Next, if I'm talking here, one thing that the concentration terms. Okay. Let's start with the let's discuss some new things. Let me explain you first what is a solution. Okay, what is the solutions and what make a things solutions. Okay, let me explain you this one first. So if I'm saying here that now you know that a solute when like for example if I'm saying that a solute solute plus solvent, okay, it gives you solution. Okay. Most of the students think that, like for example, you have sugar when dissolved in water, okay, it will give you sugar solution. Sugar, water will give you sugar solution. Okay. Now, one thing you need to tell me that what is the state of sugar crystal? What is the state of sugar crystal?
Solid.
Solid. Okay. And what is the state of water?
Liquid.
Liquid. And what is the
Liquid.
state of sugar solution?
Liquid.
Liquid. So the state of a solvent and a solution is always same. State of a solvent and a solution is always same. You understand what I'm saying? State of a
Yes.
solute and a solvent remain always Same.
Same.
Got it? Like for example, mercury. Mercury. When added to sodium, it will give you sodium amalgam. Sodium amalgam. Can you tell me that what is the state of mercury is liquid and the state of sodium is solid at room temperature and the state of sodium amalgam is also solid? Can you tell me that which is solvent here?
Mercury.
Yes,
Mercury.
Samya. Hmm? Mercury. And you,
Yes, sir.
yes, Saad, you, Sara, Anand, Anam, and Rafi. What is the solvent here? Which is solvent?
Solvent.
Yes, which is solvent here?
Sodium.
I told you the state of a solute, sorry, state of a solvent and solution is always same. Note it down. State, state of a solute and solvent are, sorry, state of a solution, state of a solution and solvent always remains same. A solution and solvent are always same. Got it? So here in this case, you check that this is mercury and this is liquid. So it is, but you see that it is solid, so it should be solvent. It should be solute, sorry, solution, and here it should be mercury should be what? Mercury should be solid.
Solute.
Okay, got it? Now you understood the concept of a solution? It does not mean
Yes, sir.
anything that is liquid is always considered to be a solvent. No, it is not so. Just so if I'm talking, there is no example. Here we have this one. Okay, solute means solute. They say the substance that is being dissolved. Okay, and the solvent is in which it is dissolved. We generally assume this one, but actual definition is the solute of the solvent is that substance which have the same state as that of solution. Okay, got it? Now, if I'm talking about this one, right, one more points in that true solution colloids in suspension, because sometimes the particle size may be asked. Okay, so write down this one, that true solutions have the particle size less than 10 to the power minus 9 meter, and here the colloidal solutions have the size between 10 to the power minus 9 to 10 to the power minus 6 meter, and they are bigger this way. Okay, so note your size, please. Do this at this point, then we shall be moving to the surface velocity. Done? Noted? The three first point only. Now moving to this part here is that we have in the colloid examples of the colloids in the dispersal phase. The dispersal phase is solute and dispersion medium is a solvent. And the type of solution is an examples. Like for example, liquid dissolved in gas. Here is a solvent. So if the solvent is gas, the solution should be also gas. If the solvent is gas, so the solution should be gas. So here you can take example of fog and clouds. When water droplets are mixed in the air, so it forms fogs. Okay. So liquid and gas are examples of aerosols and they form fog and clouds. Solid in gas, again, it is solid and then it is gas. Okay. So the dispersal medium of the solvent is gas. So the type of solution should be gas. Okay. And here is smoke is gas. Smoke is gas. Okay. So please make this chart first of all, and you have to make all these up to 8. Okay. This one is very important. One of the examples is going to come from this question. So note it down. Anam and Hanan, please turn on camera. Rafe, there.
Yes, ma'am. Yes, sir.
Note it down. You noted?
Yes, sir.
Yes, sir.
Yes, sir.
Notice 3, 4, 5. Again, if it is gas and it is liquid, okay. So the solvent is liquid, so the solution should be liquid. The form like shaving cream is like a liquid, okay. It's not a gaseous, okay. Again, liquid and liquid, the both are same though. So if the solvent is liquid, so emulsion should be liquid. So example, liquid and liquid is emulsion, like milk, face cream. So that's why milk is an example of colloids. Okay, these are all examples of colloids. Okay, these are all examples of colloids. Please don't take the screenshot. I'm going to check after the class one by one. Note it down, please. Done?
Yes, sir. Yes, sir.
Yes, sir.
Next. You done all 8. Okay. Sure. Everyone done? Aram, you done?
Yes, sir.
Arhan, Bharti, and Samia. You done?
Yes, sir.
Yes, sir.
Yes.
Today we shall be moving to the mass percentage. Okay, what is mass percentage? So mass percentage, let's move towards that portion. This is very important portion. And this is, I'm going to teach you not only the single time, but multiple times. I'm going to teach you this. Okay? So what is the what are concentration terms? I'm talking about the concentration terms. So what are concentration terms? So there are the 3 concentration terms in our syllabus. One is the mass by mass percentage, mass by mass percentage. Second one is the mass by volume percentage. Okay, so mass by mass percentage, mass by volume percentage, and volume by volume percentage. So what is actually this one? That, for example, if you have 100 gram of, like for example, the student A, okay, has 1 liter of water, 1000 ml of water, and he dissolved 200 gram of sugar into it. Okay, another students have 25 gram of water, 25 ml of water, or 250 ml of water. Okay, and he dissolved 20 gram of sugar. So if I want to ask you that which one is more sweet, this sample is more sweet or this sample is more sweet. So we'll simply say that for that we need to calculate the concentrations. Okay. So the concentration of which one is more, that will be considered as more sweet. Okay. Got it? Or what we can do is we can check we can make this one if 25 ml has such solution have 20 gram sugar. So 1000 ml of this one, for this one you multiply by 4, you multiply by 4, you will get 80 gram. So 1000 will have 80 gram, here it has 200 gram. So this means this will be more sweet. Okay, got it? So, but what we do is that we need to calculate the different concentrations, that how the different concentration terms are there. So the first concentration terms that we are going to study is the mass by mass percentage. Second is mass by volume percentage. And third one is mass by volume percentage. What is the formula for this one? What is mass by mass percentage? When X gram of solute is dissolved in 100 grams of solvent. What do you mean by the X gram? Like for example, if I'm saying 20 grams of sugar, okay, 20 gram of sugar is dissolved in 25, if I'm saying 20 gram of sugar, okay, 20 gram of sugar is dissolved in 100 gram of water. So its concentration will be 200, sorry, 20%. If 30 gram of sugar is dissolved in 30 gram of water, so it means its concentration will be water, not it total solution. Means if the total solution 100 gram of solution is going to have 30 gram sugar, it means it is 30%. Okay. But every time, do you think that we will take only the 100 gram of solution? No. Sometimes we take 50 grams, sometimes we can take 100 grams, sometimes we can get 200 grams, sometimes we can get 300 grams. So what is the formula for this W by W percentage? The formula is mass by mass, mass of solute divided by volume, mass of solution. They both have mass. W by W, mass by mass. So both are mass and mass here. So if both are masses here, so we have to use mass of solute upon mass of solution into 100. So note each and everything that is written here on the board. Okay, note each and everything. It's You done? Noted?
Yes, sir.
Yes, sir.
Yes, sir.
Next. So mass by mass percentage means mass of solute divided by means X. Everyone noted? Hanan, you noted?
Yes, sir.
Next. Calculate the mass of mass by mass when 30 gram of sugar is dissolved in 300 gram of water. 30 gram of sugar is dissolved in. Uh, uh, so please try to solve this. That you need to calculate the mass by mass percentage. Okay, so 30 gram of sugar is there dissolved in 100 gram of water. So 300 gram of water. Water is a solvent, not a solute, not a solution. Okay, so the total mass of the solution you have to keep. Okay, so please try to solve this one. Note this one, whatever written here, and then try to solve it. Mass of solute. Mass of solute is 30 gram and mass of water is 300 gram. Calculate W by W percentage. Calculate it. You done? Noted, everyone? And done? What's your answer? Yes, sir. What's your answer? What is your answer? Tell me. Yes, Samia. What's your answer?
Sir, 9.09%.
Okay, Anan, Sarah, your answer? Your answer? Seven dot 1%. So that's what the mistake that you are doing here for 1% or 10%. If you take 330 gram of the mass of solute, and 300 grams of solution. Solution weight is not 300 grams. It is 300 for the water plus 30 gram of the sugar. It is 330 grams. So if you are keeping this one at 330, so it is wrong. You should be 330 plus 30 into 100. So it should be 30 upon, should be 30 upon 330 into 1. And then 10, this 0 will cancel out each other. This will be 1 upon 11, and then it will be 100 upon 11. Okay, this will be 100 upon 11. Here you can check. And you will get 9.09. Okay, so do this one accordingly. Please do this. Done?
Yes, sir.
Next. Do this one. Calculate the mass by mass percentage. When 25 gram of salt is dissolved in 500 ml of water. 500 ml of water. Please note it now. Please note the question. First, then I'm going to explain. Calculate the mass by mass percentage when 25 gram of salt is dissolved in 500 ml of water. Yeah. So let me explain you this one here. Okay, like for examples, you have here it is saying 25 gram of salt. 25 gram of salt. So the salt is in grams, but the water is in 500 ml. 500 ml. Water is not in grams, and it is asking for W by W. So it should be also in grams and should be also grams because weight is in grams. So both should be in grams. Both should be in grams. Okay, but here it is in ml. So you have to convert this one into gram first. And there comes a concept of density. Density is equals to mass upon volume. And you know that pure density of pure water is 1. Density of pure water is 1. Okay. So you have to write here density as 1. If you don't know, like water has 0 freezing point and okay, and 100 boiling point. Similarly, you have to memorize the density of water is 1. And it is also mentioned in here also in the question that the density of water is 1 gram per ml. Okay. So if I'm talking here is that density, you know, 1, and mass you need to calculate. The mass of water you need to calculate. Okay, and the volume of water. ml is the unit for the volume. ml is the unit for the volume. Gram is the unit for mass. Okay. So we'll write here 500 ml. So when this will goes to this side, it will become mass is equals to 500 grams. When It means that if a substance which is having density 1, its mass will be equivalent to volume. Okay, because density is 1, so you can say that volume is equals to mass. Okay, so here we can write a now because the density of water is 1, so we can write that here that it is 500 ml is equal to 500 gram. Now what you need to calculate? You need to calculate W by W percentage. Now you know this is 25 grams, so write here 25 gram. Okay, and then 500 gram. 500 gram is the mass of water, but 500 gram is not the mass of solution. So you have to write 25 also here, because 25 plus 500 is the mass of solution into 100. So it will be 525 upon 25 into 100. You cut it by 25, or you can cut it by 25. 25 upon 525 into 100. So you cut it by 25, you will get 25 on the 25, and you will get 520. 25 to the 50, and then 2 and 5, 21. Okay, so it should be 100 upon 20. Okay, got it? Got it? Yes or no?
Yes, sir.
So note it down here.
Yes, sir.
Note each and everything here. Note it down, please. You done?
Yes, sir.
Okay. So that the next question we're going to discuss in the next class. Okay, so that's all for today. Thanks for coming. Okay, very good.
Thank you, sir. Thank you.
So let's move to Farhan. In the previous class, what we were discussing. Chapter 1. Yes, Farhan, I have given you something in the previous class.